Hello everyone, I'm Nidhi Chadurya and welcome back to my YouTube channel Algoptimize. Today I'm going to briefly explain the concept of implementing a stack from a list, which is also known as ListStack. Without further ado, let's get started. First, let's see what is a stack. Stack is a linear structure that follows LIFO principle. Because of that, stack is also called as the LIFO queue. The idea of LIFO is last in, first out. For an example, imagine a stack of plates at a buffet. The plate we put at last will be taken first as it is the topmost one. When talking about stacks, there are four main operations that we can perform, like push, pop, pick and ease empty. Pushing an element means adding an element to a stack. And we can push elements to a stack like this. And popping an element means removing an element from stack. And we can remove element like this. For an example, let's say we push 5 into the stack, it will be stored like this. And next, let's say we push 6, it will be stored on top of the last element we pushed into the stack. And if we perform the pop operation, it will remove the last element we added to the stack, which is 6. So when we perform pop operation, the 6 will be removed from the stack. Let's add another element. So it will be like this. And if we perform the pick operation, we can weave the topmost element of the stack. In this case, it is 7. If we add another element like 8, we have 5, 7, 8. And we perform pick function, it will return the 8. And the ease empty method for checking if the stack is empty or not. If the stack is empty, the ease empty method will return true, and if the stack is not empty, the ease empty method will return false. To implement a list stack, we can either use array list or linked list in Java collection framework. But today I am going to use linked list as it gives us the big O one, which is the constant time complexity. Big O1 or constant time complexity means that no matter how large the input is, the algorithm will take same amount of time to proceed it. Linked list is a collection of connected nodes. Each node consists of a data assigned to it and a reference to the next node. The reference will flow to this direction and not the other way around. And another important fact of linked list is that the head is always assigned to the node at the beginning. If the one is not available, the head will be at here. And to find the last element of the list, we can search for the node that has null for the next element. When we first creating a linked list, if we create it as an empty list, the head will be assigned to null. And to add elements to the list, we can add at the beginning, at the end, or at a specific position. And also for removing elements, we can remove at the beginning, at the end, or at a specific position. But the most optimized way of adding or removing elements is to add or remove at the beginning. Because if we choose to add or remove elements uh, at the end or at a specific position, we have to traverse the whole list just to add or remove some element. But if we choose to add at the beginning, we just have to add it directly like this. And when we add the element, the head will be updated as the new added element, because it is the new element, it is the node at the beginning. Now let's see how to practically implement ListStack in a code editor. Today I am going to use NetBeans as my code editor. As you can see, I have already coded two Java classes to implement the ListStack. The Java class is used to define the functions of the stack class, and the Java main class is used to run the implementation. Now I will explain the code to make you understand it more easily. First, we have to import the linked list class from Java util package, because we use this class to implement our stack. And then I have created a class called ListStack and make it as a generic class, because I want it to be able to work with different data types. Then create an object from the linked list and make it as a private object. By making it private, we can only access this object through this class only. For the first function, which is push, used to add elements to the stack, we implement it like this. We have used the stack, which means the object of the linked list, and through the object we have called the addFirst function, which takes an parameter for the element. As I mentioned earlier, we use addFirst because in linked list it is the most optimized way to add or remove elements at the beginning. Then the pop method. It is used to remove elements from a stack. For that implementation, I have checked if the stack is empty by using isEmpty method, and if the stack is empty, it will print on the console that the stack is empty. And if the stack is not empty, it will return the stack remove first function. And then peek, I will similarly check whether the stack is full or not. If it is empty, stack is empty will be printed on the console, and if it is not empty, the stack will return the topmost element of the stack by the getFirst method of the linked list class. And then for the isEmpty method I have used previously in the pop method and the peek method, I implemented it as to return the isEmpty method in the linked list class. And for finding the size of the stack, we can also use the size function of the linked list class. So let's see the implementation, how the implementation works. For this, I have made an object called stack from ListStack, uh, which is the class I have created before. And for the stack we can only use integers because we have mentioned it in here. Then I have pushed 1, 5 and 8 to the stack. By this line it should return as 3, and from this line it should return 8 because we use this function to weave the first topmost element of the stack, and from this line it should print return 8, and the 8 should be removed after this function is performed, and by this line we can see if the pop method worked properly. Let's see if it worked properly. As you can see, the first line is written as 3 because we have entered 3 elements to the stack, and the second line written 8 because it is the topmost element of the stack, and third method is also written 8 because the item will be removed after this, and the size after pop is 2. So we can say that the pop method worked properly. Now that we have come to an end, hope you have a clear idea about what ListStack is and how to implement it. If you like the content covered in this video, please like, share and subscribe to this channel. If you get any problem or feedback about the content, please feel free to leave a comment below. Thank you for watching and have a nice day.